Hello everyone, this is Mugilan from K.S.Rangasamy College of Technology. In this video, we are going to discuss about the image transformations. So, in the transformation, the basic concepts including contrast stretching and thresholding. Here, the contrast stretching means from darker to lighter, how much we are going to stretch is very important. That is, the input is R, whereas equal to the T of R. The T of R is the transformation of R. In thresholding, only like a binary image, whether two things are only available. One is black and another one is light. So here in the x-axis it is darker to lighter, and in the y-axis also dark to lighter. Here also the S equal to the transformation of R. The concept of stretching and thresholding is shown in these pictures. Image enhancement. What do you mean by image enhancement? Is a process of making images is more useful with the existing image for highlighting some of the details in images, or removing noise from the input images, or making more visually appealing for some of images. For these operations, we are in need of image enhancement. So in the picture shown here is the example for image enhancement. The left side is shown some of the blurred image. If enhanced, we can have the clear visible picture by means of enhancement. And this is another example of for image enhancement. Here the picture having less clarity or blurred of the object's eye. After the image enhancement, the eye of an object is clearly visible, and the different categories of image enhancement are spatial domain and frequency domain. In the spatial domain, directly manipulate the pixels of images, and in the frequency domain, there are different transforms are available. By means of the transform, we will convert will first the forward transform, and then we'll compute that different operations. Then we'll have a inverse transform in the frequency domain. By comparing spatial domain and frequency domain, we'll have less computations in frequency domain. Here we'll concentrate on the spatial domain. So gray values for an image having a 8-bit image means the gray level of the pixel is about 0 to 255, that is 2 power 8. So the where 0 is completely black and 255 is white. So for many of the image processing operations, these gray levels are assumed to be given as 0, 0.0, 1.0, like that, up to 0 to 255 gray levels of pixel. So next is the spatial domain, where the here the image shown here is the this pixel is the origin of the image, and this is the x-axis, and this is the y-axis. This is the mask or filter of any image. You can operate this mask and made a spatial domain enhancement. So we can represent g of x comma y equal to t of f comma x comma y. So f of x comma y is the input image given, and this is the transformed image, and d of x or y is the which kind of spatial transformations we are going to operate. So in spatial domain, whether the t is referred as the gray level transformation, and in the point processing, which is s is equal to t of or there is transformation of or. The S refers to process the image, and the value R refers to the original image pixel value. So here the negative image. So simply the image is the gray level of white. The gray levels are converted into opposite track. So the completely white and completely dark side, the pure transformation is known as the negative image. So the enhanced image means that is S equal to intensity max minus R. Once the mask is used to perform the enhancement, so once the average or any filter is applied to an original image is known as the enhanced image. So thresholding is only two kinds of pixel intensities are available. One is dark and one is negative. So 0 and 1, there is the means of threshold. So in here the threshold means only two kinds, 1 and 0. There is R less than threshold and R is greater than equal to threshold. So contrast stretching, as we have seen in the past slide, the stretching means that varying the gray levels of pixels, and thresholding means the two levels only, black and white like threshold. So the different gray level transformations in spatial enhancement or linear, logarithmic and power law. So these are some of the common gray level transformations. Here in the pixel itself, we are given the linear, logarithmic and power law transformations are given. So in the linear, the negative and identity can be transferred. In logarithmic, the log and inverse log can be done, and in the power law detector, the nth power and the nth root to be transformed. So these are the different gray level transformations are available. So far we have discussed about the spatial domain enhancement, like contrast stretching, thresholding, and the different types of enhancements, spatial and frequency domain transformations, and the pixel intensity transformations, and the contrast stretching and the brightness adaptation. Now we have closed about the gray level transformations. In concluding, the different types of transformations are discussed here. Thank you. Thank you very much.